So, you know Francesco Celani?
I know him for sure, Professor Francesco Celani, yes.
Istituto Nazionale Fisica Nucleare. He has made a criticism about your configuration.
Oh, I'm sorry. Sorry.
He has made a criticism about your configuration from a conceptual point of view, about the calorimetry. He says your method of measuring only the output temperature is not reliable, and it's more reliable configuration to run between 80 and 90 degrees by running a higher flux of cooling water. Do you accept this as a valid critique?
No, this is a nonsense.
Why not?
Because the calorimetry that we are using have been considered fit from the University of Stockholm, Professor Anno, the University of Uppsala, Professor Kullander, the University of Bologna. So I think that we use a system of calorimetry which is universally accepted.
Okay, all right. Yeah, he had. That's what he had this in one of his slides. You've seen this probably before.
Yes. Yes, but anyway, the kind of calculations we made have been made by, as you have seen, professors of physics. I think they know how to make calorimetry. Okay. There are many ways to measure, but in any case, what I think that the real calorimetry that counts is the amount of fluid that is sent to the utilization in an industrial application. So we will see it. For what concerns the calorimetry that we used is the classic standard system that is used to evaluate boilers and any kind of heating system.
Let me ask you about. You had told me I'd asked you what does the heating curve look like if there's no nuclear heat, and you said that it reaches a plateau after about 20 minutes. If it's only electrical heating, you can see the top of the curve after about 20 minutes. Do you have any graphs or pictures you can show me of the curve when it's only electrical heating and no nuclear heating?
Oh yes, is the graph that you have filmed yesterday when you assisted, when you have filmed
It's flat.
When it is flat is when we go with the LENR. When you see at the beginning, the transitory at the beginning, in that phase we are in a situation when mainly we have electric power from the resistances.
I don't know if you've ever been asked this question or not, but have you ever attempted a control experiment?
What do you mean?
A control. A control is when you have you have a hypothesis. Your hypothesis is nickel and hydrogen in this configuration make a nuclear reaction, and the control would be if you take one of those essential elements out.
I understand. Now I can. Yes, of course, we made it.
And what did you use for a control?
Many metals. Many metals. We have used iron. We have used copper. We have used all the metals close to nickel in the Mendeleev periodic table. And I have used platinum, palladium, the classic, of course, because are in the same family of nickel. And
do they work? Do platinum?
No, No, for a lot of reasons. No, also because the bigger is the atom and the bigger are the Colombian forces. So going to platinum and palladium, you go in very difficult fields.
If this is a confidential question, just you tell me so. Is nickel the only thing that works? Is nickel the only metal?
To answer this question, I would have to explain to you the role and the nature of catalyzers. And this is an issue that I still am conservative with. Okay. I am sorry.
Let's talk a little bit more about your paper. A new energy source from nuclear fusion. In January, you and I spoke, and you wrote to me, I think that the definition, cold fusion, is wrong in itself. What I claim is a weak nuclear reactions energy. So, did your point of view change?
No. My point of view did not change. You can call it weak, you can call it low energy, but I am still convinced that the definition cold fusion is wrong. I would not call it like that. I think that low energy nuclear reactions is a commonly accepted. May I interrupt a second? Scusate, dovreste andare a parlare di là, per favore. Grazie.
Well, you called your paper nuclear fusion.
Yes, because yes, you have nuclear fusions, but when you say low energy nuclear fusions, they are nuclear fusions.
Another thing from your paper, it says tests were made in your lab with the assistance of the Department of Energy and of the Department of Defense. Can you explain what you mean by that?
No, because I am under confidentiality agreement. We worked with them, we are still working with them, but I am under confidentiality agreement. I cannot absolutely talk about that. I am sorry.
Okay. Can you say if there was any kind of contract, any federal contract?
No, not so far. No.
Okay, no contract.
No.
Okay. All right, and let's see. We're moving good. Okay. One question about history, and you probably know, as I, there is a saying that when you have someone who thinks of an idea, maybe that's important, maybe it's not, but often it's the man who takes an idea and makes it useful and makes it practical, provides a direct benefit to society that provides something worthwhile. Do you give Francesco Piantelli any credit for some of the ideas that have formed the foundation of the science for nickel hydrogen research?
Honestly, the work that he made is totally different from the work I am making. If I have to, if there is somebody that gave me an idea that I develop, that this somebody is Fleischmann and Pons, because this has been their original idea. Yes, Piantelli has worked with nickel and hydrogen, but in a completely wrong way.
How is his...
Under my point of view.
How is...
No, I am sorry. I never talk about the work of my competitors publicly. I am sorry. I want not to talk about Piantelli is a competitor of mine. So my deontology forbids me to talk about the work of my competitors. I am sorry.
So just so you know, my question was, and if you don't want to answer it, it's okay, but my question was, how is your work so different from Piantelli's? But if you don't want to answer that, that's okay.
I cannot enter in. You can see the effects. We are making plans which work.
Okay, very good. Thank you.
You're welcome.
Now, how about Professor Levy? How did he become part of the team?
No, he is not part of the team. Okay. Professor Levy is not of our team. Professor Levy is a professor of the University of Bologna. Focardi, of course, is an emeritus professor of University of Bologna and is retired. And when we decided to make a public presentation of our work, Focardi said that a public test had to be made, and and he proposed to make it with the University of Bologna because he knew everybody there, and it was easier for him to organize a test. And Professor Levy is the one that had interest in doing this test. He was very interested, so he.
How did he learn about it?
From Focardi.
Okay.
From Focardi, because Focardi still has an office in the university, and so he was in contact. He is in contact with the professors, and Levy told him that he would have been very interested to make the test, and that's it. And same thing for Dr. Bianchini. When I needed tests of an expert about radiation to check that the shieldings were all right, I asked to Focardi whom I could call, and he said Bianchini is our specialist in the university, and I called him. But Levy is not Levy is an employee of the University of Bologna and of the University of Cesena. He's not of our team.
Clear. Okay, thank you.